So we're getting temperatures at the moment, it's around 150 degrees centigrade, and we actually have these downhole tools, and one of them has actually failed because of that hot temperature, which is good and bad. Bad because it's expensive, good because it's really hot.
Welcome to ESC Live at Eden Geothermal here in St Austell, Cornwall.
What we're doing today is learning about a very special kind of renewable energy that's so important for Cornwall. This is going to make a superb industry for Cornwall over the coming years. Geothermal is so important because it's a continuous energy. It's a type of energy that can be extracted constantly and consistently, whereas, as you'll all know, whilst solar energy and wind energy are absolutely fantastic, they're fairly intermittent and very dependent upon the weather.
Every time Adam tells me about renewable energy, I just want to go and study it all over again because it's so inspiring. So what are you going to be learning about today? Well, you're going to be, first of all, meeting some amazing site engineers and experts and geologists who are working here in Cornwall at the Eden Geothermal site.
So I'm the project manager for our geothermal project here. We're really fortunate down here in Cornwall in that we have this thing called the Cornubian batholith, and that is an outcrop of granite. When we drill, it's warmer here than it is elsewhere. What we're going to be doing is we're drilling this hole down to here, and then we install a coaxial heat exchanger. And the coaxial heat exchanger goes inside our hole to around 4,000 metres. And then we pump cold water or cool water down the edge of the coaxial heat exchanger where it heats up, and then we pull hot water back up the heat exchanger. Then we send that hot water steam down to the Eden biomes to heat the Eden biomes. So phase 2 of the project, after we've drilled this first well, and if we have a permeable zone, so we have a target zone, we want to pump cold water down here through this fractured zone to heat it up and then pull hot water back out. Then we send that through a turbine, through a binary plant process, through a turbine where it produces electricity. We send that electricity to the grid, and we still send hot water and steam down to Eden as well.
Hi everyone, I'm Maddy. I'm the geologist on site, so I'm part of the well on-site well geology team. So our job on site is to analyse all the samples that come up from the well behind us. So many of you will have heard of countries such as Iceland and New Zealand, which are known for their geothermal energy. And actually, even though the UK is away from plate boundaries and we haven't got a volcanic heat source, we do have an incredible rock called granite. In this granite, we have minerals potassium, thorium and uranium. And over time, these minerals decay, they break down. And as they do this, they give off heat. So we can actually harness this heat.
We have got the question, how hot does the geothermal structure get?
Yeah, okay. So as I've just mentioned, because of those radioactive decaying elements, we get temperatures down below it at 5 kilometres up to around 200 degrees Celsius. I grew up in Cornwall, and Cornwall's got a really rugged landscape. It's surrounded by granite, so I've always had a passion for the outdoors and geology, really. So my sort of interest in geothermal, I guess, stemmed from back in geography in school. Following on from doing geography, I went and did geology at both college and university, and here I got to explore all different types of skills in geophysics, geochemistry, mathematics, written and analytical skills, and I've been able to apply all of this through, firstly, an internship with GeoScience Limited, and I was then kept on and as a technical assistant, and I'm now a geologist working here at Eden.
Robbie, can you tell us a little bit about what you do here on a day-to-day basis?
So I'm the drilling engineer on site. So it's my job to work with the team that we have on site to ensure that we actually get to our target depth and hopefully we're going to hit a fault location. This is the drilling rig you have here. There's a big piece of pipe that comes out of the bottom of this yellow block there. That's called our top drive. Imagine that piece of pipe is lots of 30-metre sections connected together to reach the very, very bottom. And on the very, very bottom, we have one of these drill bits. So if you look here on the far right-hand side, that's an 8.5-inch drill bit. So imagine a telescope. It starts off at the bigger size and you pull it all out. At the far left-hand side, you can see we have a 26-inch drill bit. So it started at 26 inches. We then went to 17.5 inches. And then here we got 12.25. And our final section is the 8.5 inch. And this is where we hope to hit our fault.
And we've had some questions actually about, because we're calling it a fault, and I think a lot of people have this association about seismology. Can you tell us a little bit more about that and maybe, address some of these fears?
Absolutely, yeah. So because it's naturally fractured, it allows us to flow water within that fault region. Now, the difference between that and fracking is that the rock is naturally fractured. And what fracking does is it creates artificial fractures. And that's when they pump very, very high pressure and they crack the rock open. We don't need to do that here because we have these fractures existing already. At depth, we're expecting it to be anything from 4 to 5 meters to maybe 20, 30 meters across. First off, I studied a bachelor's in mechanical engineering, and then I did a master's in petroleum engineering. And once I'd finished that, I went and worked offshore for a company called Schlumberger. And I spent 5 years going from rig to rig across Europe and the Middle East. It basically gives you a lot of the skills that you learn in the oil and gas industry, especially when it comes to drilling, and a lot of the exploration practices are very, very transferable to geothermal.
It's really great to hear that there's kind of a transition that potentially people who are already trained in oil and gas or working in the industry can make to geothermal, which is really renewable and very, very exciting.
The project that we've seen here today is one of the very first enhanced geothermal power plants in the whole world. If this project is a success, we will start to see other projects building like this all around Cornwall. This can be a fantastic industry, new clean industry coming out of Cornwall.
So hopefully you've enjoyed today and learnt loads and been really inspired by the amazing engineers that we've met. We just wanted to show you really quickly some actual granite that's been extracted from the well.
This is one of our latest samples from 4,000 metres below our feet here.
It's an incredible depth, 4,000 metres. That's a really long distance that they're drilling all the way down into the ground. So thank you very much for joining us, Redruth and Paul, and thank you very much from all of us here. Bye.